Dear learners, hope you are doing good. Welcome to the module on developing pseudocode. Like flowcharts and algorithms, pseudocode is another problem solving technique. We have already discussed about algorithms and flowchart in our earlier modules. We have also seen how to draw and execute the flowcharts using the Raptor tool. In this session, we are going to learn about pseudocode and how it helps in getting solutions to the problem we are trying to solve. So, what is pseudocode and in what way does it differ from programming language or English like language? Pseudocode is generally written more close to a programming language. A pseudocode is an informal way of describing a program, but not a computer program. Pseudocode can be considered as a rough copy of the program. It can use natural language or mathematical notation. There is no standard syntax for pseudocode. So, you do not need to worry too much about the syntax and format for a pseudocode. Pseudocode style vary from one to another. Okay, so what is pseudocode? Pseudo means imitation and code refers to instructions. It is a way of describing an algorithm without using any specific programming language related notations. It is written using plain English statements. It is also known as programming language design. As I told you earlier, a pseudocode does not have predefined syntax. So, let me tell some commonly used terminologies that may be used while writing pseudocodes. First, let us see the keywords that may be used for reading input from the user. The keywords are read, obtain, get may be the keywords for reading the input from the user. For showing the output, we may use print, display, show, etc. Assignment or process can be written using compute and calculate. The keywords like compute, calculate may be replaced with assignment operation, that is an arrow marked pointing towards left. The format of the assignment operation can be seen on the screen. Right side, the value is assigned to the left side variable. For example, the area of a circle can be calculated and assigned to the variable as shown in the console. So, here you can see that the example, we compute the area of a circle using the formula 3.14 into r, that where 3.14 refers to the pi value of pi into r square, which is computed and assigned to the variable area. Are you clear about the keywords? The logic for the program to be solved can be given through algorithms, flowcharts and pseudocode. As we have already discussed flowcharts and pseudocode, let us walk around pseudocode in this module. To mention logic to the given problem, we may use sequential, selection and repetition structure depending on the nature of the problem to be solved. Foremost, we will see a few examples for sequential structures. Let us now see how we can write pseudocode for our good old problem, that is the problem of making coffee. Every pseudocode begins with the keyword begin and stops with end. Please notice the pseudocode over the console. Here you can see the pseudocode begins with the keyword begin and ends with the keyword end, and in the middle you have the statements for getting input from the user, that is for the purpose of making coffee you get the input, that is water, milk, sugar, coffee powder, then the process of boiling the water, adding coffee powder, adding sugar and adding milk, then stirring operation, then the operation of pouring the coffee into the cup, then serving the coffee. Got it? Let us now write a pseudocode to find the sum and average of n numbers. So, here you can see that this block of code begins with the keyword begin and end keywords, and in the middle the first statement is the get a b c, where a b c are the 3 numbers you get from the user as input. The second statement adds the 3 numbers and assigns to sum, and the third statement computes the average by dividing the sum by 3, because we are having 3 numbers as input, and the final statement displays the sum. It is not so simple writing pseudocode, is it not? We will write a pseudocode for one more example. Consider the problem of swapping values of 2 variables. Here the first statement gets 2 values from the user, that is the first and second. These values first and second are going to be swapped. To swap 2 values we need a temporary variable. So, we create a temporary variable by the name t. We assign the value of the variable first to t, then the value of the variable second is assigned to first, and the value of t, which actually holds the value of the variable first, is assigned to second. By these 3 statements the values of first and second get swapped, and then the final statement displays the value of first and second. Following these sequential structures, next we have selection structures. So far we have pseudocode which behaved in a fairly linear way. We run every instruction in the pseudocode in sequence from top to bottom. We do not really solve problems in only one predetermined way. We need to be able to solve more general problems that have an element of choice in what statements they execute. We need a way to control if some statements are to be executed at all or to be skipped at all. This is done using the if, then, else or case statements. Okay, let us now move on to the basic pseudocode constructs for selection. I repeat that there is no standard syntax for writing pseudocode. So, we present what we generally follow. Selection is the construct we are going to see the first. The 2 different selection constructs are if, then, else and case. The first selection construct is if, then, else. In the modules on flowchart and algorithms, we have discussed how if else works. The if construct is used to execute the selected sequence based on the condition. The if construct has 4 keywords: if, then, else and end if. The syntax for if, then, else is shown now. So, you can see that the first line starts with if, followed by an expression that represents the condition, then followed by the keyword then, followed by an indentation. We can have statement or a sequence of statements, then followed by else, which is unindented, and within the else we have again a sequence of statements, and the total construct is demarked by the keyword end if. The else keyword and the sequence 2 are optional if the condition is true, and sequence 1 is performed, otherwise sequence 2 is performed, right. Got it? Okay. Shall we see a few examples using if, then, else construct? First example is to find the biggest among 2 numbers. So, you can have a look at the pseudocode to find the maximum of 2 numbers. So, here we get the 2 numbers, we call it a and b from the user. We use an if statement. If the condition a is greater than b, then display a as greatest. If a is not greater than b, then the condition a greater than b becomes false. In that case, the else part is executed and the value of b is displayed, and this is completed with the end if statement. Shall we rewrite the previous pseudocode such a way that it finds the biggest of 3 numbers? You can now see the pseudocode for finding the maximum of 3 numbers. So, here we get a 3 numbers from the user, now we call it A, B and C. Then we compare 2 variables, that is at a time, like for example, A greater than B and A greater than C. So, if A is greater than B and A is also greater than C, then A is the greatest among the 3, we display A. If any one of them is false, either A greater than B or A greater than C, then we check if B is greater than C. If B is greater than C, then we display B, else if all the 3 conditions fail, then we display C. So, this is again an example of a nested if else block. Next, we will construct a pseudocode to find the grade of a student given his or her marks. Pseudocode to find the grade based on marks. So, we get the marks, and if the marks happens to be greater than 90 and if the marks happen to be less than 100, that is if the value of marks happens to lie between 91 and 100, then we grade it as yes. Then we use if the mark is less than 90, then if the mark is greater than 80 but less than or equal to 90, we grade it as A. If the mark is less than 80, less than or equal to 80 or greater than 70 and greater than 70, then we grade it as B. Similarly, it goes if the mark is less than or equal to 70 but greater than 60, we grade it as C. And finally, if the mark is less than or equal to 60 but greater than 50, we grade it as D. If the mark happens to be below 50, then we grade it as RA, that is reappear. Then we display the grade. So, here this is an example of a nested if else ladder. I hope you would have understood how to use the if then else construct. Okay. Next selection construct is the case. By and large, we use if then else if we have a very few number of choices, that is 2 to 3 choices. If an expression evaluates to a number of choices, that is cases, then the case constructs may be preferred over the if construct. In our earlier pseudocode, that is used to find the grade is a good example of having many choices. Instead of if then else, it could be good if we use the case construct. Therefore, the case construct indicates a multi-way branch based on conditions. It consists of 4 keywords: case, of, others and end case. The conditions are used to indicate the various alternatives set of statements. Please note the general form of case construct. The general form of case construct is the keyword case with followed by an expression and the keyword of, followed by condition, followed by a colon, then a sequence of statements, condition 2 colon sequence of statements, and we can have up to n number of conditions. Then we have a default sequence. If any one of these 1 to n is not satisfied, then the default sequence is executed. The case expression, the case statement ends with a end case keyword. The other clause, which is its default sequence, is optional. Conditions are normally numbers or characters in some programming languages, but it need not be so for a pseudocode. Let us now rewrite the pseudocode to find the grade of a student given his or her mark using the case construct. Pseudocode to find the grade based on marks. So, now we get the marks, case followed by marks, marks is the marks the condition of, and now we write the conditions, case, that is marks, that is condition, that is marks less than or equal to 100 but greater than 90, then we call it grade, we assign S to the grade. If marks is greater than 80, but less than or equal to 90, we grade it A. So, this goes on till the last option, that is, if the marks is greater than 50, but less than or equal to 60, then we grade it D. If none of these options are valid, then the others is executed, wherein we assign RA to grade and we end the case and finally display the grade. Do not you feel case is better than if, than else when there are multiple choices? Yes, case construct is more elegant compared to if else when the number of choices are more, like in displaying menu, etc. Then what is next? Of course, the third construct is repetition structures. These structures are useful when we want a set of statements to be executed for a specific number of times. In our earlier modules on flowchart and algorithms, we have already discussed about these structures. Let us now see what are the general repetition structures used in pseudocode. Pseudocode has 3 repetition structures. They are while, repeat, until and for statements. The repetitive structures are also called as iterative or looping structures. We will have a look at them one by one. First one is the while. The while construct is used to specify a loop with a test at the top. The beginning and ending of the loop are indicated by 2 keywords while and end while. Can you recollect the 2 types of looping while we discussed in the last module? What are they? They are the conditional and counting loops. While is a conditional loop. This is because it decides the number of iterations based on the condition. The general form of while loop can be seen now. So, here you can see the while construct starts with the keyword while followed by an expression that represents the condition, and we have an indentation. The statements which are indented after the while come inside the while scope, and we have a sequence of statements in the while that are repeated again and again by the block, and finally we end with the end while. So, the loop is entered only if the condition is true. The sequence is performed for each iteration. At the conclusion of each iteration, the condition is evaluated and the loop continues as long as the condition is true. Let us construct a pseudocode using while construct. Consider the problem of reading and adding the numbers until the number -1 is encountered. Here we do not know the number of iterations, it depends upon the user input. See the pseudocode for this problem. In the pseudocode you will find that we start with assigning a value 0 to the sum, and because we are going to find the sum of numbers entered by the user until the user enters -1. Next we are going to use the repeat construct. So, going to repeat the statements below. So, gets an input number A, and when A is not equal to -1, A is an input from the user. If A is not equal to -1, we add A to the sum. Sum is initially initialized to 0, therefore, the first sum will be equal to A. Then we get A from the user. Again, if the A happens to be a positive number, again the number A will be added to the sum. This process will repeat as long as the user chooses to enter a positive number, but as the user enters -1 as the input, then the condition becomes false and we exit the loop, and finally we display the sum. Next repetitive structure is repeat until. This loop is similar to the while loop, except that the test is performed at the bottom of the loop instead of at the top. 2 keywords repeat and until are used. The general form is, so we have the starts with the keyword repeat followed by an indented statement sequence of statements which come under the repeat sequence, and the keyword until followed by a condition. Here there is a caution that you should exercise is while condition and the until conditions you have to give it properly, because in while what we do is as long as the condition is true the while is executed, but here in until will be executed as long as the condition is false, and when once the condition becomes true it is exited from the repeat sequence. The sequence in this type of loop is always performed at least once, because the test is performed after the sequence is executed. At the end of each iteration the condition is evaluated and the loop is repeated if the condition is false. The loop terminates when the condition becomes true. Now, let us rewrite the problem of adding the numbers until the number -1 is entered, which we have just now written using the while construct. So, here we again proceed the same way as we have done. Here we assign the sum to 0, then we use a repeat keyword and we get an input from the user, we call it A. If A is not equal to -1, then sum equal to sum plus A, that is we add A to sum and assign to sum, and this is repeated until A is equal to -1. So, the moment the user enters -1, this loop is exited and finally we end up displaying the value of sum. Please do remember that like while, repeat until is also a conditional looping construct. You may use any one of them if you do not know the exact number of iterations. The next and the last looping construct is for. This loop is specialized construct for iterating a specific number of times. If you exactly know the number of times the loop is to be iterated, then you can use the for construct. So, it is a counting based loop construct. Two keywords for and n for are used. The general form is, so you start with the keyword for and a followed by a variable, and this variable is assigned values from a start value, initial value and an end value with an optional increment or decrement by number, and the sequence between for and n for are repeated for that many number of times. Suppose we want to add n numbers. Here n is the input to be given by the user. Say for example, n could be 10 or 20 or 30 etc. We need to read n numbers and add them. As we here know that the number of times the statements to be executed or repeated, we prefer to use for rather than while or repeat until. The pseudocode can be written as shown. So, here again we begin with assigning 0 to sum, then we use the for construct. For count is the variable which is going to count the iteration from 1 to n, 1 to n starts with initial value of 1 and to the final value of n. We get input from the user and call this input as A, add A to sum and repeat this for n times, and we know the value of n since we have got it from the user, and once the count becomes n, the loop is exited and we end up displaying the sum. To get a better understanding, let us write the pseudocode for another problem of finding the biggest of n numbers. So, here you can see that we begin by getting a value n, and also we get another variable number. So, here we are going to get n numbers from the user, and as we get n numbers we are going to find which is the biggest number. So, the first number we get from the user we assign to the variable biggest, thinking that is the biggest number. Now, for count equal to 2 to n, okay, so we have, since we have already got the first number, So, the next number is 2, second number to the nth number, we get a number, and if that number happens to be greater than the biggest, then we assign that number to the biggest variable, and if that number happens to be, and if the present number happens to be less than the biggest, then we do not do anything. So, that is taken care of by the if then end if block, and this construct is repeated for n times, and after n times we come out of it, and whatever is left in the biggest is the biggest of the n numbers we got from the user. Hope you would have understood writing the pseudocode using various constructs. A looping construct may be placed within another looping constructs. For instance, a for construct can be placed inside a for or while or repeat until and so on. Such a looping construct inside another looping construct is called nested construct. Let us write a pseudocode involving nested looping constructs. Here we need to find the sum of the series 1 factorial plus 2 factorial plus 3 factorial up to n factorial. So, this pseudocode you can see computes the sum of series 1 factorial plus 2 factorial plus 3 factorial up to n factorial. We know what is 1 factorial. 1 factorial is 1 and 2 factorial is 1 into 2, that is 2, and 3 factorial 1 into 2 into 3, that is 6, so on. So, we begin with by getting a value n from the user, that is the up to how many terms you need to find the sum. We initialize fact to 1, fact stores the values of the factorials, and sum to 0, sum stores the values of the sum of the factorials. Now, we use a for construct to compute the factorial. For count from 1 to n, we know that we have already assigned the fact to 1. Now, for no, that is the number from 1 to count, we keep on multiplying the number to the fact. Okay. Initially fact is 1. So, first number 1 into number is that number. So, second number is, and what we do is this number is incremented. Okay. So, first number will be 1, then 2, then 3. So, fact will become, if a number is 1, the fact is 1. If number is 2, the fact is 1 into 2. If the number is 3, the number is fact is equal to 1 into 2 into 3. So, this continues. So, finds the factorial, and when after computing the factorial, it adds the factorial to the sum. Sum is equal to sum plus fact, that is adding factorial to the sum. So, now here the thing is that you can see there are two constructs, two for loops. The outer for loop actually computes the sum, the inner for loop computes the factorial. So, together these two factorials, these two for constructs are nested structures, and finally, when you exit both the for constructs, and you finally end up displaying the sum of factorials. Hope you got it. Before concluding, then let us now enumerate the advantages of pseudocode. A pseudocode allows the developer to express the design in a natural language. It is easier to develop program from pseudocode than with a flowchart. It is easy to translate the pseudocode into programming language. It should be compact and concise. With its benefits, a pseudocode also has few limitations. A pseudocode does not provide visual representation of the program logic. No accepted standards for writing pseudocode, and unlike flowchart, it cannot be compiled or executed. So, it is time to wind up this module. To conclude, in this module we have discussed the basics of pseudocode. We saw how to write pseudocodes using various constructs. We have also explained how to write pseudocodes for a set of problems. I reiterate that there is no one defined way of writing pseudocode, but a pseudocode should possess three elements: clarity, precision and concise. If you have more questions, post them in the discussion forum. Thank you.